Hello, everyone. Welcome to CXO Spice. CXO Spice is a platform for thought leaders to share their point of view on innovation and explain how to make it happen in the real world. I'm your host, Helen Yu. Today's topic is Data Moves AI. I have a special guest here, Kunal Anand. He's the Chief Product Officer at F5. Hello, Kunal. Welcome to CXO Spice.
Hi, Helen. It's so great to be here, and thank you for having me.
Likewise, and before we dive into this exciting topic, let's have you introduce yourself and tell us a little bit more about your role at F5 and your journey to your role today.
Would love to. So at F5, I lead product. So that means I spend most of my time thinking about how the world's most demanding enterprises move, deliver, and secure applications, APIs, and we'll get into it, I'm sure, today, AI and agents. Prior to F5, I spent my career building and securing infrastructure at scale. I've worked at tech startups as an entrepreneur, exited that to some large companies. I've also worked at some of the largest platforms on the internet, social networking, back when it was just an infant idea, a company called MySpace. And then prior to that, I was at NASA. I worked at the Jet Propulsion Laboratory and specifically working on programs like the Mars rover and James Webb Space Telescope.
Wow, not many executives can say they've worked at NASA, JPL, and that's quite a varied path. And I'm really can't wait to learn more from you, right? There has been quite a bit of hype around AI infrastructure right now, Kunal. What's the gap between what vendors are promising and what's required to run AI reliably at enterprise scale?
I'm actually really glad you asked this question, Helen, because look, you as a practitioner, you've seen this before, right? You've seen cycles come and go. And sometimes there's always this gap and this divide, right, between hype and reality. And the gap is massive. I think the gap is also hiding in plain sight. I think most of the hype today is really focused on the model layer. Like who has the best foundation model, who has the most parameters, who's winning benchmarks. But if you go and you talk to the teams actually running AI in production, the number one problem isn't the model, right? It's keeping the model fed. It's keeping those GPUs working. Idle GPUs, right? The thing that we hear a lot about as technology leaders, idle GPUs, they're the most expensive failure mode in AI right now. You have organizations that spend millions or billions on compute.
Mhm.
And the GPUs are just sitting there waiting for data. And they're waiting for data because the pipeline that gets set up between storage and compute just can't keep up. And I know we'll probably dig into it today. You've probably seen this before. And I think, in some of your other interviews, people kind of allude to it as, a data delivery problem. Uh, I don't think anyone in our industry, and to go back to your question, I
Mhm.
don't think anyone in the industry in this vendor ecosystem that we all live in is talking about it honestly. I think enterprises aren't struggling to pick a model. I think they like their various AI models that they're using. I think they're struggling to build reliable and performant data paths that can scale. And I think that's where the real work is.
Absolutely. I share your observation, Kunal. That gap between promise and reality gets sharper the moment you start moving data at scale, right? That actually brings us to something that's often overlooked in the AI conversation because most people think about AI performance comes down to the model itself, the parameters, the architecture, the training data. But what's the really case for why data movement and delivery infrastructure is just as critical as AI outcomes?
I think this is a super important question. Uh, And the way I would kind of try to think about it is like this. You can have the most advanced model in the world,
Mhm.
but if you can't get training data to the GPUs fast enough, those GPUs idle. And also if you can't serve inference results back to the application or the API, whatever it is that's calling the model reliably, then the user experience breaks. The way I would like to sort of frame this, and we a couple of weeks ago at F5, we had our analyst investor day,
Mhm.
and the way I kind of frame this to analysts to sort of take a step back when you think about the ecosystem is the model is the brain, right? I don't think anyone is disputing that. Like that's
Mhm.
where the intelligence lives, uh, the delivery layer, the data delivery layer, the infrastructure around it, that ecosystem, that's the sort of circulatory system, the nervous system of this whole machine. And the thing that surprises people the most, to go kind of go back to what you were describing, is that S3, so the simple storage service protocol, has become the de facto protocol for AI pipelines. Things like object storage, well, that's where training data, embeddings, checkpoints, people talk about retrieval augmented generation. So all the corpora that's being sort of used for RAG,
Mhm.
all of that is S3. And then you kind of take a step further, S3 is all HTTP. And that means that the data path that feeds these AI workloads is just fundamentally an application delivery problem. And for us as an organization, that became pretty apparent 2 years ago
Mhm.
because we at F5, we've been solving application delivery over HTTP for 25 years. The way the company was built was serving application delivery use cases. And all that was, for the early generation of the internet, the first generation of the internet. And so for almost 30 years now, we've been doing this. And with AI, I feel like the world kind of handed us a new, incredibly high stakes use case for a problem that we already know how to solve.
Yeah. If data movement is that fundamental, Kunal, it's worth asking where is it really actually breaking down in production today? And what are the most common failure points you've seen? Is it latency, throughput, reliability, or something else entirely?
I think it's D or E, all of the above to what you said. I think if I had to rank it though, I would say throughput and reliability are the silent killers of most workloads. We speak with a lot of organizations that are running AI factories at scale. Many of the customers that we serve, they have fleets of racks of GPUs. They have fleets that are just dedicated to AI. What we hear from them and what we've seen practically is that latency is the thing that sort of gets all the headlines, like when
Mm,
something is really latent or it's just taking too long to process. That's the thing that gets all the buzz and all the attention. It's, when you think about all the GPUs, like when you go to NVIDIA GTC or you see all the latest benchmarks, all of that is really prioritizing things like throughput, right? So it's prioritizing things like latency. But I think what actually takes AI pipelines down is the bursty demand that overwhelms object storage. So I
mm,
think it's more reliability focused. And
mm,
and what I mean specifically is, you have these sort of training jobs, as an example, that spins up, and their job is to try and absorb and pull in a lot of data that you may already have in S3 because these are training runs. You want to use existing data that you have to
mhm,
train these models, or maybe you have a fine-tuning run. And what you're typically doing is you're pulling large amounts of data from things like S3 storage, again, going back to that, and those storage clusters buckle under that weight. And S3 sort of became the common thing that people use. So when I say S3 buckles, I don't mean Amazon buckles. That's not what I'm saying. You have a lot of organizations today that deploy S3 compatible storage in their local environments, in their data centers, in their offices, wherever they've got data. And when reliability issues hit, that's usually when you have shifting endpoints. It means you've got pipelines that stall.
mm,
I think the failure mode isn't dramatic. It's not like when one of these GPUs or when something breaks in the data delivery pipeline fails. It's not like a dramatic failure. It's more of like a slow bleed. It's more like a slow degradation of service.
mm.
You see like jobs taking longer, GPUs go underutilized, and that's when the operations teams totally come into play because then they're left trying to figure out why the expensive infrastructure they have is underperforming. And I think what you actually need is that delivery tier between compute and storage that can absorb the volatility. So I think it's really more of a reliability problem.
That's such a refreshing point, right, Kunal? These failure points are exactly where F5's heritage becomes directly relevant, as a matter of fact, because you have deep roots in application delivery and traffic management. So, how has that expertise translated into solving problems that are unique to frontier AI infrastructure?
I'm, this is the fun part now. And you know this all too well. You know, you can be at an organization working away in what you call your own quote industry or your own sort of vertical, serving customers. And along comes something like AI, which, when I think we all got our hands on AI in the chat GPT moment many years ago, I think we all just thought very simply, okay, it's some new experience with the model, but I don't think anyone really appreciated the depth and sort of the second order effects, the third order effects. We're many years in, maybe we're talking sixth or seventh order effects now. And it's also why I love this particular moment for F5.
Mhm.
We just celebrated, and we're celebrating this year 30 years. And
Congrats. Yeah.
or thank you. Yeah, no, and we wouldn't be here if it wasn't for the amazing, amazing work that prior generations, for 30 years, it's not like it's the same people over 30 years. There have been multiple generations of people who've come in with their ideas of what they want to do and how they want to build the company. But for all those years, we've been in the business of putting these intelligent control points between users and applications, things like load balancing, traffic management, security work, resilience work. And the pattern actually turns out to be the exact same for AI. You can swap users out for things like GPU clusters and applications out for stuff like object storage. And then when you place big IP between compute and storage, it does what it's always done. It stabilizes throughput, it protects the backend from bursty demand, it keeps data flowing. But now it's keeping things like training jobs, fine-tuning runs, inference pipelines fed instead of just keeping web apps responsive. And the part that I love the most is that it's the same control point that handles delivery, but also handles security and governance. So we can inspect that S3 traffic. We can detect and block unauthorized access. Everyone's talking about agents today. This blows my mind because we're going to have agents all over the place. As an organization, we have agents deployed everywhere, just probably like a lot of other enterprises. And as these agents kind of go around, they collect data from lots of different places. You're going to need to have to detect what these agents are doing,
Yeah.
blocking unauthorized access, trying to protect APIs that are touching the storage to give people more visibility. So I think the way I kind of look at this is I feel really excited about the opportunity. I think to your point, you asked the question on and you framed it around deep roots. You're absolutely right. Deep roots here. And for us and for me personally, I look at this as an opportunity for us to provide delivery and security from this sort of single architectural layer.
Well, especially you, right? Being a former CISO, you know how to build the governance from day one. That transition, as a matter of fact, translation from application delivery to AI infrastructure is one thing, but the product itself has had to evolve, right? GPU cluster, model inference pipeline are a very different kind of challenge. So kudos to that vision and evolution F5 has been having. ADC, let's talk about ADCs, right? Like big IP weren't originally designed with GPU clusters and model inference pipelines in mind. So how has F5 had to evolve its product thinking to meet the demands of modern AI native enterprises?
I think what's evolved is how we think about what sits on either side of the ADC. And for those that have not heard that term before, ADC, application delivery controller.
Mhm.
And um, F5 kind of made that term. We built that term, 30 years ago. And in the past, the two sides of ADCs used to be clients and servers.
Mm,
And when you think about AI factories, it's GPU clusters and object storage. The protocol is still HTTP. It's just the traffic patterns are different. They're more sustained, they're higher throughput.
mhm,
Uh, they the request response is just different. It's more large objects going back and forth. It's more streaming,
mhm,
and we've got to tune for that. Like there's more protocols now. There's things like MCP, there's S3, there's AI specific protocols. So we've had to teach our products these new tricks for how to understand these new protocols, how to use them. So S3 is a great example, right? It's over HTTP. And I think where we've had to evolve our thinking over the last couple of years is while we support S3, really how are people using this protocol for feeding data to and from these GPUs? And so our evolution in thinking has been kind of let's go back and look at these protocols again in the context of AI, because it's clear that maybe we need to do something different. Maybe we need to change the way that we optimize for object storage, uh, protocol support. Maybe there's things that we need to do differently. And that's ultimately what's led to the product breakthrough. So, like how we think about decoupling AI applications from the underlying storage infrastructure, making it easy for organizations to potentially swap out storage vendors. How
Mm.
do they rebuild nodes? How do they migrate clusters? How do they move AI workloads without people never noticing? And that is a very different narrative for us. So I would say it's really the evolution of not just thinking about ADCs as something that only exists between clients and servers, but thinking about ADCs just more fundamentally of, okay, I can control, I can shape traffic, I can secure traffic. Maybe I can do this now within these massive AI factories to make things more efficient, more secure, and allow people to quite easily govern and shape what needs to go where.
Well, that product evolution reflects what enterprise leaders are now being forced to grapple with, right? I actually work with a lot of leaders don't really yet know what to look for when assessing their own infrastructure readiness. So let's say, Kunal, if you were a CTO, which you were one before, or CIO, trying to
Yeah.
assess whether your current infrastructure can support AI at scale, what are the 2 to 3 things that should really you should prioritize?
Okay. And you're making me miss my CTO days by asking me the question. The purity of those days of and as an aside, right? It must be, for CTOs right now, this moment has just never been better, right? To be in this industry because you have such amazing tools and technologies to play with. The landscape is so dynamic now than ever was before. Um, but if I'm in this world right now, and if I think about that data delivery problem that we're describing, I would say there's probably three things I would look for.
Mm,
The first would be GPU utilization.
okay.
Uh, you probably bought a bunch of GPUs because you knew that you'd be under load, right? You
Yeah.
you you sized it based on your inference requirements, which therefore means that you have the traffic, you have the data, whether it's for inference or training.
Mm,
So I would first check your utilization.
okay.
If the GPUs are just underutilized and your team can't explain why, the bottleneck that we've seen, Helen, is typically that most people uh, are having a problem in the data path. You
Mm,
have a delivery problem. You don't have a compute problem. You have a delivery problem. If you don't have a utilization problem and you've got the capacity and you've got the goods for inference and training, then
mm,
it's a delivery issue.
okay.
And then the second thing that I would take a look at is the storage resilience under load.
Mm,
And so the way that we sometimes see this show up is, and I would suggest for those who are tuning in, try running a test,
mm,
spike demand on your object store, and
okay.
see what happens. What you'll typically notice is that the throughput will degrade, or you get things like client errors when a storage node goes down,
Mm,
and when that does happen, you don't have a delivery tier that's just protecting that pipeline. You're
mm,
only one node failure away from things like a stall training run. And the third thing that I would probably recommend, I'm trying to decide between if this is, I don't want to give you four. I want to only give you three.
okay.
So I think the third thing is probably visibility into the
Okay.
data pipeline itself. Like for example, can you see what's flowing between compute and storage? Can you detect an anomalous access pattern? And when you get into the AI factory itself, inference now is disaggregated. Some of your listeners may have heard that term. Disag is a thing that sometimes shows up. Um, Inference is hitting both prefill and decode. And for those that don't know what that means, go hit your AI up and go ask that question and go learn something really, really interesting. But there are many blind spots that are now showing up there
Mm,
with respect to delivery. So I would say those are the three things.
okay. I took a good note from you, Kunal. Number one is GPU utilization. Number two is storage resilience. Lastly is visibility. These actually signals become even harder to read when your environment is spread like cross clouds and on-prem, and then hybrid
Mhm.
multi-cloud add whole other layers of complexity to this challenge. So how does that complexity compound the data delivery problem for AI workloads?
It just makes everything harder. Yeah, when you live in a single cloud world or a single environment, and let's just pick on, a single cloud world. Let's say you're only in AWS or GCP or
Mhm.
OCI or Azure. The cloud provider abstracts a lot of the data path complexity for you.
Yeah.
The reality is most enterprises aren't single cloud. They've got things like training happening on on-prem GPU
Mhm.
clusters because that's where their data lives. Are they
Yeah.
really going to send data to the cloud to go and train things in the cloud, or are they going to train things locally? This is where on-prem object storage comes into place. Sometimes they may not have the GPUs locally and they may train in the cloud and it's acceptable for them because just they don't have the allocation to get the GPUs where they are. They're okay. They make an exception to get the data to the cloud. They train, they run fine tuning there. But when it's done, where do they run the inference?
Mhm.
Again, the other sort of side of this is, you asked the question at the beginning and the gap of hype versus reality. I think there's also a big sort of delta between people building small language models and large language models. I think most organizations, when they say that they're training a model, they're SLMs, right?
Right.
And so the SLMs don't necessarily need GPUs or large GPUs to run. Uh, we're one of those types of organizations. We have both LLMs that we built as well as SLMs too. And you know, again, you think differently because when you have an SLM, you don't necessarily need GPUs, so you can kind of deploy those things anywhere. But if you have LLMs, then now you really need a GPU to get the best performance out of it. So all this is to say that each of these environments that I'm describing, all of them are going to have different storage endpoints. They're going to have different performance characteristics. They're going to have different failure modes. And without that consistent delivery and security layer across all of them, yeah, I just know that CIOs and CTOs and CISOs, they're managing so much fragility.
Mm.
And I think this is where, for us, things like vendor neutral or vendor neutrality, I would say, makes sort of like the most sense.
Yeah. I
We
would agree.
we when we were building this capability or these capabilities for data delivery, we wanted to do this across the board, regardless of the underlying storage type. So, for example, we have organizations that use Dell Object Scale, some that use NetApp, some that use MinIO, some that use Scality, right? And really any S3 compatible platform or on-prem in the cloud, to us it doesn't make a difference. The point is that you shouldn't have to re-architect your data delivery layer every time you change a storage vendor or add a cloud, and the control point needs to be consistent regardless of what's underneath.
Yeah, so cool that you meet with a customer they are at rather than force them to change their infrastructure architecture, right?
But you've been there before. You've been there
Yeah,
before. I mean, like,
absolutely.
how many times have you had vendors come to you, in your past life or past lives where they've said, "Yeah, look, we got this great solution, but it's going to require
Mhm.
you to re-architect." I mean, what did you do in the past when that happened?
Oh my God, we'd have to look at current state versus future state. Spent weeks or
Yeah.
months to map everything out, right? Migration, right? You talk about, you name them, APIs, all these connection points. But I'm so glad we have solution that can really meet with customer can stay
Mhm.
where they're at. So with all that complexity as a baseline, it's worth looking ahead because the infrastructure challenge of today are only the beginning. So
Oh
where
yeah.
do you see the biggest unsolved problems in AI infrastructure over the next 18 to 24 months, and how is F5 positioning itself to address them?
All right. I think there's three, again, power of threes. I
Mhm.
think that's kind of repeating. Um, there's three things that generally keep me up at night with respect to AI infra. The first is AI data security. So you brought up the point before. I served as a chief information security officer before. And if I put on that hat, I think data security with respect to AI is completely immature.
Yeah.
I think most organizations have a strong perimeter, and they've got strong security around their apps and APIs, but the data pipeline that's feeding AI models is completely wide open.
Hmm.
Things like poisoning, exfiltration, unauthorized access to training data. I think those are pretty real threats. We've heard stories, we've seen things. I obviously can't name names about customers or what they've experienced, but I don't think most enterprises have much visibility as to what's going on when they're building these models. And, that's part of each one of these fears is sort of leads to how I think about product and my teams think about product and like what we want to do to sort of help there. That's sort of like fear one, which then leads to why we believe that we have an ability to be this sort of inspection and enforcement layer
Hmm.
inside that pipeline and not just at the edge. And of course, for inference too, right? You think about like that problem with data security for inference. Oh my goodness, like how do I know that people aren't stealing my model through
Hmm.
distillation? How
Hmm.
do I how do I know that people aren't trying to use this model for prompt injection or whatnot?
Hmm.
The second one is just in general, the operational complexity
Hmm.
of AI infra is just going to get worse before it gets better. You can
Yeah.
see it already, like more models, more data, more environments. I think the organizations that win will be the ones that try to simplify the stack, will be the
Totally.
ones that simplify their delivery and security across all of this. And that's what we want to try and help people do. And then the third one is I think the industry is going to realize that the last mile of AI,
Hmm.
which is sort of getting data to compute reliably and securely, is
Hmm.
just going to be as important, or if not even more important than the model itself. We've seen the pattern before in the application world, and we have spent 30 years building a company around solving that problem for apps. We're now going ahead and doing it again for AI. So those are the three things that I can see.
That's really profound, Kunal. I can't agree more with you, right? With that kind of horizon in view, let's bring it back to what matters most for leaders listening today. Here are the four key takeaways from our conversation. Number one is AI performance is an infrastructure problem, not just a model problem. The quality of your model matters, right? But if your data delivery layer is slow, unreliable, or bottlenecked, your AI outcomes will suffer, like you described earlier. Latency, throughput, and reliability at that data layer are as important as anything happening inside the model. Uh,
Mhm.
Number two is the failure modes in production are specific and knowable. You gave us some example earlier. Organizations don't really have to wait until things break. There are clear signals, right? The three things you talk about, the GPU utilization, storage resilience, and visibility, all those signals can really guide the organization to understand whether their infrastructure can support AI at scale. And then number three is a hybrid and multi-cloud environment multiply the data delivery challenge. When AI workloads are distributed across clouds or on-prem, the problem of moving data reliably and at speed becomes really hard. Unified traffic management is no longer optional. Yeah, you gotta have that. And then lastly, the next 18 to 24 months will separate infrastructure leaders from laggards. I love the three-point you really highlighted, right? The AI data security is really important because enterprise invest now in that scalable, resilient data delivery and partner with infrastructure platform built for AI native workload. So critical. Number two, I mentioned about the operational complexity. So you got to simplify your operational
Mhm.
model, make sure it's simple enough so that you can really keep up with it. And I also love the fact you mentioned about last mile AI. It's so critical. And then you have to make sure you build for AI native workload, have that meaningful head start as demands continue to grow. So, Kunal, thank you so much for such a grounded and technically clear conversation. Your perspective on where AI infrastructure is heading and what it takes to get it right is exactly the kind of clarity that technical leaders need right now. And we're so glad you brought it to CXO Spice today. And thank you, everyone, for listening. And stay hungry, stay bold, stay grateful.